Okay, so here we go. Now we're going to talk a little bit about the atom. I'm not quite sure what you guys know, but I want to make sure you have some good foundation for it. We're going to start setting the stage for the periodic table, and we'll get into that later. But right now, let's go ahead and get some basic notes on this, and I would definitely recommend you write them down. Notebook's a great place. So, real quick, what is an atom? Well, an atom makes up all things. Okay? Everything around you is made up of atoms. Okay? All sorts of different types of atoms. Now, atoms are the basic unit of matter. If it exists, it's composed of atoms. Okay? One thing to keep in mind. Now, atoms themselves are made up of pieces. We call those subatomic particles. Sub means below. So these are things that are below the atom. Okay? They make it up. Now, keep in mind, these are things that make up. They're smaller than the atom themselves. We can barely see fuzzy outlines of atoms. Okay? There's no way we can see the things that make them up, but we actually have ways to find out that they are there. Okay? So with that, let me move myself. Let's go ahead and fill this out. You're going to see a chart like this later. And subatomic particles, there are 3 subatomic particles. And you should be familiar with them. I'm going to move myself over here. You should have heard probably some of them, and we'll go from there. Now, one of the first ones you heard, where's my pen? Oops. There we go. One of the first ones you've probably heard about is the proton. Now, proton, what are some other ones? Well, you've heard of a proton. You've hopefully heard of an electron. And you may or may not have heard of, which one? That's right, the neutron. Okay, so those are the particles themselves, proton, electron, or neutron. Now, let's go ahead and figure some things out. If we look at the symbol of the proton, you're going to see it 2 ways. This is a lowercase p, or you'll see it as a p+. Now, the electron is a lowercase e, or you'll see it as an E-. And for neutron, you can probably figure that out, lowercase n. Why lowercase? It sounds good. Actually, it can deal with the fact that we have some elements that have those for symbols. Now, the charge. If we look at a proton, pro actually means positive. Okay, if you're pro something, that means you're for it. So a proton has a positive charge. Electron, if you look at the symbol, kind of gives it away. It's a negative. Neutron, the root of neutron is neutral. So we say it has 0 charge. Now, if you know anything about the atom, you actually know about where they're found inside an atom. If not, let's go this way. A proton is found in the very center of the atom. The center of the atom is called the nucleus. Okay. Now, the nucleus actually contains one other thing besides the proton. The neutron also contains the nucleus. The nucleus contains the neutrons. There we go. So where does that put the electrons? Well, oddly enough, the electrons are found in the electron clouds. Sometimes you're going to hear these referred to as rings. And when we get further in, we're going to give them another name as we apply it, called periods. Okay. Those are the 3 things there. Now, because these things make up atoms, and atoms are the foundation of all matter is made up of. Well, matter has mass. That means atoms have mass. That means the things that make up the atoms have to have mass too. I'm not going to go into the specifics behind what they are. I'm just going to give you the values. A proton has a mass of 1. Technically, it's 1 AMU. We're just going to use the number 1. AMU stands for atomic mass units. Yeah, scientists were a creative group. Okay, so protons have a mass of 1. Now, neutrons also have a mass of 1. They're almost identical in size to the proton. A little bit different, but that's okay. The electron, though, is the difference. Electron, in reality, its mass is 1/1837th of that of a proton. Now, that pretty much, think about it this way. You were to stand on your bathroom scale and you were to you see your mass, you were to rip out 1 eyelash and then you drop it on the floor. The amount that your weight just changed would be kind of what you would see in terms of an electron. Let me see if I can get rid of this little thing. There we go, sorry. Okay, so pretty much it's meaningless. So in reality, we say the mass of an electron is 0. You would have to have 1,837 of them in one spot to equal the mass of a proton. Not happening. Okay, so hopefully that makes sense. Going to the next one. Now, proton, neutron, electron. Okay, very good. Now, just a summary. And why are we not sorry? Sorry, guys, this is new technology for me. And let's go back over here. Apparently, I hit white ink. Okay, well, this is unique. So, with that, I'm going to go ahead and pause here and I'll splice these in. Okay, let's do a quick review of the 3 subatomic particles, what we know so far. On the protons, we know it has a positive charge. We know it's found in the nucleus. And lastly, we know it has a mass of 1. That's all we know so far. Now, the neutron, we know it has no charge. Think neutron, neutral. It's also found in the nucleus. And it also has a mass of 1. Okay, though that becomes important. Now, in terms of the electron, electrons have a negative charge. They're found in the electron clouds. And we say they have a mass of 0. Remember, it's an extremely small mass. It might as well be 0 for all our purposes. Okay, so keep that piece in mind. Now, do this real quick. Okay, some basic notes. Okay, atomic number. This is a term we're going to be using quite a bit. The atomic number is the number of protons in an atom. Okay, you're going to be wanting to pause the video and write this stuff down. Okay, now, no 2 elements have the same number of protons. That means no 2 elements have the same atomic number. And if you know the atomic number, you know exactly what element it is. That's why that atomic number is so important. Okay? It's giving us the identity of the element itself. And once again, no 2 elements have the same atomic number. So if something has 2 protons, atomic number 2, helium. If I can go across anywhere in the universe and I find something that has just 2 protons, it's helium. Next one, atomic mass. This is a key one. This is why we need to know the mass of the proton and neutron, because the atomic mass, the mass of the atom, is based on the number of protons plus the number of neutrons. If I know those 2 things, I can get the mass of that atom, how heavy it is. Okay. And if I know the atomic number, I automatically know the number of protons. Number of neutrons, that's a different way. Okay. When you look on a periodic table, you're going to find out the mass, and I'll show you where to find that in a second, is actually going to be a decimal. Okay. Now, number of protons cannot change. Number of neutrons actually cannot change. In fact, you can't have part of a proton or part of a neutron. That's what I mean by that. Either you have it or you don't. It's like you don't have 1.2 people. Either you have a person or you don't. Okay, same thing. It's going to be based on what's called isotopes. And that's why that has a decimal. We're going to see that more in a second. But first of all, I need you to copy down some stuff. Isotope. These are atoms of the same element. Once again, same number of protons, but they have different numbers of neutrons to them. Okay, so atoms of the same element, same number of protons, but they have different number of neutrons. Well, why is that important? Why do we care about that? Well, if you have different numbers of neutrons, that's going to give you a different mass. Okay? And when we talk about the masses of atoms, we're actually talking about an average. Okay? It's an average of a whole bunch of atoms. We're talking billions and billions and billions and billions of atoms to give us that mass. Okay, real quick, atomic number, briefly, number of protons. Atomic mass, it's the number of protons plus the number of neutrons. So I want to go through here real quick. So let's say I've got this. If you had a periodic table handy, number of protons is 6. That means it's atomic number 6. Atomic number 6 is element carbon. Okay. So all of these have 6 protons. They're all the exact same element. Now the number of neutrons can vary. And that's what we're looking at here. Now, if I were to go through, and figure out the mass, remember mass is protons plus neutrons. The very first one, it's 12. Next one, 13, 13, 12. Sorry, my numbers are getting a little off. And 13. Actually, 14 on the last one, sorry. I'll correct that in a second. Whoa. Let's go this way. There we go. That's 14. A little bit off, but we get the idea. So if I wanted to figure out the actual mass of the atom, it's an average. So just like you get an average, you add up all of the pieces, and you divide by how many are actually there. So 25, 50, 61, 71, 75. And I believe there are 6 elements there. If I were to look at that, I would come up with an average of 12.5. That would be my average atomic mass. Okay. That's why we have a decimal when you look at the periodic table. Okay. Next piece. Oops, sorry about that. When you look at your periodic table, you're going to see a lot of different designs, and I don't have a copy of it right now, but go through there. You're going to see basically the periodic table. You've seen it before, big table as to, well, all the elements. Very top, you're going to see this, and obviously that's a name. Now, you're going to see a number, and you're most likely going to see a number that has a decimal. Well, once again, we just got done saying that is going to be the atomic mass. You're going to see this big letter. And there are always going to be letters you're going to be familiar with. That's the symbol of the element. And that's what we're going to use when we start talking about compounds and things like that. You already know some of them. You know CO2. You know H2O. Okay, those are actual symbols that represent elements. That's how basically we talk. And on the bottom one here, this is the atomic number. And the atomic number is your number of protons. Couple things, one of the main things I need you to know, because we're going to be going through that. In an atom, the number of protons, I'm just going to use the symbol of P+, is always going to equal something. Remember, protons have a positive charge, right? An atom has no charge. Okay, they cancel out. If every atom had a positive charge, they would never want to get together. It's like poles of a magnet. If they're both negative, they'd never want to get together. That means an atom has to have no charge. So if I've got so many protons, so many positives, I have to have a corresponding number of negatives. So the number of protons is always going to be equal to the number of electrons.